Okay, so in this lesson we're going to look at linear equations that will have no solution or an infinite number of solutions, which we'll say will be all real numbers. Okay, all real numbers. Okay, so let's consider the following linear equation. So we have 2 times x plus 1 is equal to 2x plus 3. Now what I want to do here is just to show you that if we substitute, let's say, a number 4, let's say the value 4 for x, and if I plug that back in into the equation, so I get 2 times 4 plus 1, and I want to see that's going to equal 2 times 4 plus 3. And so if I use the order of operations on this side, I get 4 plus 1 is 5, and then 2 times 5 is 10. And over here, using the order of operations, I get 2 times 4 is 8, 8 plus 3 is 11. So 4 is not a solution. Alright, so if you want to try, let's say, let x equal negative 2. Let's see what happens. So if I let x equal negative 2, I'm going to get 2 times negative 2 plus 1, and I want to see if that's going to equal 2 times negative 2 plus 3. And so using the order of operations, negative 2 plus 1 is negative 1, and 2 times negative 1 is a negative 2. Over here, 2 times negative 2 is negative 4, and negative 4 plus 3 is negative 1. And so those are not equal. So x equal negative 2 is not a solution either. And no matter how many of these numbers you use, if you let x be any real number, so if you let x be any real number, if you substitute any real number in for x, the equation will not be a true statement. Okay, and so what that means is that this equation has no solution. Okay, so let's see why. So I'm going to go ahead and rewrite the equation again. So I have 2 times x plus 1 is equal to 2x plus 3. Okay, so based on what you've already learned, in order to solve this equation, you're going to use a distributive property. And so I get 2x plus 2 is equal to 2x plus 3. All right, and then remember the next step was to bring all the variables to one side. Now I want you to notice something. See how the term that involves the 2x, they're identical? So I want you to notice that when I subtract 2x from both sides, both of those like terms, they're opposites on both sides. So this is 0, and this is 0 as well when I combine like terms. And so your statement that's left is that 2 equals 3. And so if you look at this statement, then notice the variable's no longer there. The variable's no longer there. So what's happening is that either you're going to get no solution, or you're going to get all real numbers as your solutions. So to determine that, you look at this final statement. So this final statement says that 2 equals 3. Well, we all know that 2 does not equal 3. That's a false statement. And so what you're going to say then in terms of your solution is that there is no solution. Okay, so this equation has no solution. So when the variable disappears, when there's no longer any variable in your statement, you look at that final sentence, that final statement, and you ask yourself, is it true or false? So since this is a false statement, then that means that no matter what you plug into the original equation, no matter what you plug into here, no real number will work. And so you say no solution. So you just say no solution. But this is a process you go through. You go and you solve this until you get that final statement and you determine whether it's true or false. Now, you only do that if the variable disappears. So notice in the previous problems we've done, there was always one solution. Now we have a situation where we have no solution. Okay? All right, let's look at another one. So let's suppose we had this one. Suppose we had 4 times 3x. Let's make that number 1. All right, so 4 times 3x plus 2 is equal to 12x plus 8. All right, And so if I use the distributive property, I get 12x plus 8 is equal to 12x plus 8. All right, now you can look at this right here and see that no matter what you plug into x, I want you to notice this. If you plug in 0 for x, 12 times 0 plus 8 is 8. 12 times 0 plus 8 is 8, so 8 equals 8, so 0 is the solution. If you plug in 1, do you see that these sides are identical? Those sides are identical, so no matter what you plug in for x, this side will always equal this side. So if you plug in 2 for x, 12 times 2 is 24. 24 plus 8 is 32. Same thing here. They're identical. So what that means is that in terms of your solutions, well, if you were to bring the variables to one side, if you do that at that point, and you combine like terms, see how the variables disappear, but you're left with 8 equal 8. So if you compare the previous one, we had a statement when the variables disappeared, we had a false statement, so we said no solution. Here, the variables disappear, we have a true statement, so this is a true statement. And so your solution will be all real numbers. So you say all real numbers. So no matter what number you plug into x, it's going to work. So you have an infinite number of solutions. All right, so in the previous lessons, when you solved equations, you only had one solution. Now you have a situation where you have no solution or all real numbers. You have an infinite number of solutions. Okay, so notice what happens when the variable disappears. You're either going to get a true statement or a false statement. If it's a false statement, you say no solution. If it's a true statement, you say all real numbers. All right, and then it's kind of made sense that this, see how these sides are identical? So you are going to have all real numbers as your solutions. All right, let's get number 2. So number 2, let's suppose we had 2 times x plus 3 minus 5 equals 5x minus 3 times 1 plus x. All right, so using distributive property on both sides, and over here we can distribute the negative 3. So here I get 2x plus 6 minus 5 equals, and over here I get 5x, and when we distribute the negative 3, I get negative 3 minus 3x. So negative 3 times 1 is a negative 3, and a negative 3 times a positive x is negative 3x. And when I combine like terms, I get 2x plus 1 is equal to, and then 5x minus 3x is 2x minus 3. Go one more step. Just go one more step. Bring the variables one side. Get to that point. And so when I get to that point, I notice that when I combine like terms, the variables go away, and you get the statement 1 equal negative 3, which is a false statement. And so notice when it's a false statement, you're going to say, in terms of your solutions, you're going to say no solution. No solution. It kind of makes sense there would be no solution because look at this statement right here, this equation. 2x plus 1 equal 2x minus 3. See how the 2x's are identical? So no matter what you plug into x, these two terms are identical, but here you're adding 1, here you're subtracting 3. There's no way they're going to be equal to each other. All right, and so you get a false statement. All right, let's do one more. So that was a very simple objective. So let's say we had, let's say we had negative 2 times 6x minus 5 plus 4 equal negative 12x plus 14. All right, so using distributive property, so we're going to distribute the negative 2. We get negative 12x. A negative 2 times a negative 5 is a positive 10 plus 4 equal, and then negative 12x plus 14. Combining like terms, I get negative 12x plus 14 equal negative 12x plus 14. All right, now you see how they're identical, so you know that no matter what you're going to plug into x, this side will always equal to this side. See, if you plug in 0, see how these two terms are identical, and these two terms are identical, so both sides are equal to each other. They look exactly the same, so no matter what you plug into x, this side will equal to that side. So you know that you're going to get all real numbers as your solutions. But go one step further. You got to show this step. So add 12x to both sides. And when you add 12x to both sides, you get 14 equal 14, which is a true statement. And so what you say, though, is that in your answer, don't say true statement, you got to say all real numbers. That's what you put, all real numbers. Okay? All right, that takes care of that lesson.